Today's most powerful new telescope isn't made of glass and steel. It's made of code. So let's dive into how these large language models, or LLMs, are becoming this essential and pretty controversial new instrument for exploring the cosmos.
What's so wild about LLMs is just how different they are from any software we're used to, right? We expect our apps to be predictable, reliable. LLMs, they're just not. They can totally stumble on simple, repetitive tasks, but then they excel at things we thought were uniquely human. Writing, brainstorming, even creative coding. It makes them both incredibly powerful and, honestly, a little bit baffling.
And the scale of this shift is, well, it's historic. To put it into perspective for you, the productivity gains we're seeing from LLMs are somewhere between 20 and 80%. The steam engine, the thing that literally powered the Industrial Revolution, only gave us an 18 to 22% boost. So this isn't just another software update, it's a complete revolution in how work, especially scientific work, gets done.
That's why it really helps to think of an LLM as a totally new kind of scientific instrument. It's like a telescope, but instead of gathering light, it gathers and processes information, helping scientists make sense of the just vast oceans of data in modern research.
So, how are astronomers actually using this new instrument? Well, a recent survey shows this isn't science fiction, it is happening right now. Get this, a massive 92% of them are using LLMs for coding assistance. 72% are using them for writing help, drafting papers and things like that. And about a third are using them as a kind of superpowered search engine to answer really specific scientific questions.
So what does this AI assistant actually look like in a researcher's day-to-day workflow? Well, in practice, it's streamlining some of the most time-consuming parts of the entire job. This really breaks it down into three key areas. First up, literature review. An LLM can summarize and compare academic papers in minutes, not weeks. Second, scientific coding. It can generate, debug, and even document the complex code that is the absolute backbone of modern astronomy. And third, academic writing. It's an incredibly powerful editor that can help draft an entire paper or just, help you rephrase a single tricky sentence. And the impact on coding is something you can really see. A full 83% of astronomers using these tools say they finish coding tasks way faster. Over 60% say they can write more code in the same amount of time, and almost as many find it helps them squash bugs more efficiently. I mean, that is a massive boost in productivity. But here's the catch, and it is a big one. The experts really stress the need to be the human in the loop. See, an LLM is an aid. It's not an oracle. It makes mistakes, and if there isn't an expert there to catch them, those mistakes can end up in published science. So, the crucial point here is that this is a collaboration, not a replacement. Which brings us to the dark side of this technology. For all their power, there are some pretty significant risks, what you might call the ghosts in the machine. These are the built-in flaws that we have to learn to navigate.
And the most famous ghost of all is something called hallucination. This is when an LLM just confidently makes stuff up. It generates information that sounds totally plausible, even really technical, but it's completely false. And because it's so convincing, it can be dangerously misleading. Here is a perfect real-world example. An LLM stated that magnetohydrodynamics assumes a collisionless plasma. Now, to an astrophysicist, that is a huge red flag. They know the exact opposite is true. But for a student or a non-expert, this highly technical, very wrong statement looks completely legitimate. That is the danger of hallucination in a scientific context.
And this opens up a really fundamental, almost philosophical question for science. When an AI helps write a paper, whose ideas are we actually reading? Is it a genuine insight, or is it just a very sophisticated remix of all the AI's training data? This one question leads to a whole host of ethical problems.
The ethical landscape is, frankly, a minefield. First off, there's credit. Most scientists agree that LLMs should be cited as a tool, but in reality, they rarely are. Then you've got bias. These models are trained on the internet, so they can absolutely reproduce and even amplify existing human biases. And on top of that, there's copyright. Many models are trained on copyrighted work, raising some serious legal and ethical questions.
So, given this incredible potential on one side and these really serious risks on the other, what's the path forward? How do we chart a future where this technology actually serves science responsibly? For individual researchers, the guidelines have to be crystal clear. First and foremost, you are 100% responsible for everything in your work, whether it's AI-assisted or not.
That means you have to maintain a critical mindset. You have to fact-check absolutely everything the AI produces and always, always treat it as a helpful assistant, not as a definitive source of truth.
But that responsibility doesn't just stop with individuals. Scientific journals and institutions also need to set up some clear guardrails. This means enforcing author responsibilities, protecting confidential manuscripts from being uploaded to public LLMs, and building systems to detect AI-generated spam and fake citations. But maybe most importantly, they have to lead an open debate on how to use these tools ethically.
When you boil it all down, this is really the key takeaway. The goal of using AI in science is to augment human expertise, to supercharge our critical thinking and our creativity, not to replace it. The astronomer is still the one looking through the telescope. The AI just helps them see a little bit better.
So the question isn't if AI belongs in science, it's already here. The real question we have to ask ourselves is how we build the guardrails to make sure this powerful new telescope helps us see new stars we've never even imagined, and not just a reflection of our own old ideas.